Hey guys, today we're going to learn how to multiply and divide rational expressions. Now when you're multiplying and dividing rational expressions, it follows the same process as when you're multiplying and dividing fractions. When you're multiplying fractions, the good thing about it is that you don't need a least common denominator like when you're adding or subtracting. Instead, you just multiply numerator with numerator, denominator with the denominator. Now with rational expressions, you're not going to actually physically multiply. What you're going to do first is you're going to write all of the factors that next to each other, and then you're just going to start canceling things out and then writing out a simplified version of the rational function. So for example, in this first one here, we have x plus 1 over x minus 1 times 3 over 2 times x plus 1. When we're multiplying fractions, we just multiply numerator with numerator, denominator with denominator. So we would write this like this. We're not going to actually multiply. We're just going to write those factors in the numerator all together. So this would be 3 times x plus 1 over x minus 1 times 2 times x plus 1. And then we cancel any common factors. In the numerator and the denominator, they both have an x plus 1. So we would cancel that out. So now my final answer would be 3 over, we always write the number in the front, so 2 times x minus 1. And I don't expect you to actually distribute anything. So this would be your final answer. Now in this one in B, it's a little bit more complicated because as you can see, this was already factored out, but this one is not. So what you have to do when you have a multiplication problem like this is you need to make sure that everything is completely factored. So we're going to go through each of these rational expressions and factor it all out. So we have this 3x squared in the numerator, which cannot be factored because it's one term, over x squared minus 2x minus 4 can be factored to x minus 8 times x plus 2. Since negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So this is now factored. Times. Now x squared minus 3x minus 10. This can be factored to x minus 5 times x plus 2. Since negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. Over. Now here we have x cubed minus 6x squared plus 5x. This is not a quadratic function that I can factor like this one. However, I do notice that every single term has an x. So I can take out an x first, and that would give me x squared minus 6x plus 5. And now I can continue factoring this quadratic here. So I have the x, and then I have x squared minus 6x plus 5 can be factored to x minus 5 and x minus 1. Since negative 5 times negative 1 is positive 5, and negative 5 plus negative 1 is negative 6. Now we put them all together. If you want, you can just draw one big fraction. That means that this factor times this, and then these factors all together. And now we start canceling anything that is the same in the numerator as in the denominator. So we have these x minus 5s. We also have these x plus 2s that I can cancel. And then we have here this x, and then this is x squared. So that means that I can cancel out this x with one of these, because x squared means that it's x times x. So basically, I just took one away. So now the only thing left in the numerator is this 3x, and then what's left in the denominator is x minus 4 times x minus 1. And this would be my final answer. Remember, you don't have to actually distribute anything. You can just leave it like that. Let's try a couple more. We have here x squared minus 9 over x squared minus 5x minus 24 times x minus 8 over 2x squared minus 18x. So let's factor everything. X squared minus 9 is a difference of squares, so that can be factored to x plus 3, x minus 3. x squared minus 5x minus 24 can be factored to x minus 8, x plus 3, since negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5, times. In the numerator, we have this x minus 8 that cannot be factored, but in the denominator, we have 2x squared minus 18x. Both of these terms have a 2x in common, so I can factor out the 2x, and that would leave me with x minus 9. And now I can start start canceling. Since this is multiplication, this is just one big fraction with all of my factors together. I can cancel out these x plus 3's as well as these x minus 8. And the only thing now left in the numerator is the x minus 3 over, in the denominator, 2x times x minus 9. And this would be my final answer. Last one for multiplication here. We have x squared plus 8x. Let's factor that, which they both have an x in common, so I can take out an x, and that will leave me with x plus 8. Now in the denominator, we have this 14, and we can factor x squared plus 8x plus 5 as x plus 5, x plus 3. Sorry, 15. I keep doing that. 5 times 3 is 15, and 5 plus 3 is 8. Times. Then we have this 7x plus 35. Both of these terms have a 7 in common, so I can factor out the 7. And that would leave me with x plus 5 over x plus 8. Now that everything is factored, I can just turn this into one giant fraction and start canceling. These x plus 8's will cancel, the x plus 5's will cancel, and so what we're left with in the numerator is 7x over 14 times x plus 3. But this can be further simplified because of this 7 and 14. We can simplify 7 and 14 by 7. So I can divide this 7 by 7 and divide this 14 also by 7. And so 7 divided by 7 is 1, so we're left with x over 14 divided by 7 is 2, and then x plus 3. So you always want to make sure that your answer is as simplified as possible. Now let's look at division. And division is very similar to multiplication. The only thing is you have one additional step. When you're dividing fractions, most of you know it as copy, change, flip. And if you don't, that's fine. But basically what you do is you take the first fraction and then you multiply by the reciprocal of the second fraction. So what we do is we're going to copy the first fraction, change to multiplication, and then flip the second. So we'll do that first. So we have x squared plus 14x plus 49 over x squared. I'm changing this to multiplication, and then we get x squared plus x minus 2 over x squared plus 9x plus 14. Now this is a multiplication problem, which is what we've been practicing. So now we factor everything. X squared plus 14x plus 49 can be factored to x plus 7 times x plus 7, since 7 times 7 is 49 and 7 plus 7 is 14, over x squared, that cannot be factored, times x squared plus x minus 2 can be factored to x plus 2, x minus 1. Since 2 times negative 1 is negative 2, and 2 minus 1 is positive 1. Over x squared plus 9x plus 14 would be x plus 7 and x plus 2. Again, since 7 times 2 is 14, and 7 plus 2 is 9. Since this is multiplication now, we can just make this into one giant fraction and start canceling. I can cancel out one of these x plus 7's. And I can also cancel this x plus 2. So my final answer here would be x plus 7, x minus 1 over x squared. Let's try a few more. We have here 20 over x squared minus 7x divided by 5x squared minus 40x over x squared minus 15x plus 56. So I'm going to copy, change, flip. So because we are dividing. So I'm going to copy this first fraction, 20 over x squared minus 7x, change to multiplication, and then we would have x squared minus 15x plus 56 over 5x squared minus 40x. So I flipped that second fraction. Now let's factor. We get 20 over x times x minus 7, since both of these have an x that can be divided and factored out, times x squared minus 15x plus 56, the two numbers that multiply to give you 56 and add to give you negative 15 are negative 8 and negative 7. So x minus 8, x minus 7, over 5x squared minus 40x, both of these terms I can take out a 5 as well as an x. So 5x, and then I would end up with x minus 8. Now again, since this is now multiplication, I can turn this into one giant fraction and start canceling. I can cancel out these x minus 8s as well as this x minus 7. So the only thing left in the numerator is 20 over, and then I have this x times 5x, which is 5x squared. Now the 20 and the 5 can be simplified by 5, or you can just think about it as 20 divided by 5, which is 4 over x squared. Or again, you can do it like divide by 5, divide by 5. 20 divided by 5 is 4, 5 divided by 5 is 1, which we never really have to write. So this would be my final answer. Last one here, I'm going to copy, change, flip first. So 6x over 3x minus 30. Change to multiplication, and now flip. X squared minus 10x over 9x squared minus 27x minus 36. So now let's factor everything. The numerator cannot be factored for that first rational expression, so we leave it as 6x. But the denominator here, I can divide both of these numbers by 3. So I'm going to factor out a 3, and I would get x minus 10 times x squared minus 10x. Both of these here, I can take out an x, and that would give me x minus 10 over. Now when I look at all of these numbers here can be factored, can be divided by 9. So I'm going to take out a 9 first, which gives me x squared minus 3x minus 4. So I have this 9, and then x squared minus 3x minus 4, the two numbers that multiply to give you negative 4, but add to give you negative 3, are negative 4 and 1. So my factors would be x minus 4, x plus 1. And now we start canceling. Now the only thing that I can really cancel is the x minus 10s. So what I have here in the numerator is this 6x squared over, then I have the 3 and the 9. 3 times 9 is 27. And then we have x minus 4 over x plus 1. But 6 and 27 can be simplified. Both of these numbers can be divided by 3. So I'm going to divide both of those numbers by 3. 6 divided by 3 is 2, so 2x squared, over 27 divided by 3, which is 9. And then x minus 4, x plus 1. And this would be my final answer. And that's it for multiplying and dividing rational expressions.